Okay, today we want to talk about another type of transistor tester called the transistor junction tester. It tests the junctions in the transistor. We'll go over what they are in a few minutes. But anyway, what basically it does is it'll detect the short between each of the leads of the transistor to see if it's working or not. You can build one out of LEDs and a switch. Make sure your LEDs have a resistor for it, or have a built-in resistor, so that it will current limit it to a safe value, so your LED don't break and your transistor don't break. So, and we'll go over this basic operations too as well. You can make this if you want to at home. Very simple and easy. I got the ones you put in the car that are 12-volt one, but ones on 9 volts as well, pretty well. There's 4 of them. You need 4 of them in order to do this project, this tester, because you gotta test both the 2 pins on the transistor. So each 2 LEDs represents the 2 ends. Anyway, let's go over the basic operation of this whole thing. Okay, here we go. Here's the junctions and the transistors that they go to. Transistors can be thought of as 2 diodes back to back, like that. But the thing is, you can't make transistors just like that. They're not made like that. This is just showing you how the junctions are inside of them, and we can test the junctions for multimeter, or you can use this junction tester that we made to do the job for us. Do exactly the same thing on a multimeter do. Anyway, what we see right here is N is like the cathode on a regular diode, the N junction, and a P junction is like a anode on a diode. And they go back to back on a transistor in PN, as you can see. And what you're supposed to detect is that when the voltage is flowing to here, it should flow up to here and to here, and at a certain polarity. Not both polarities, at only one. That makes it. We'll have a switch on our tester that will be able to switch on and off, switch between the positive or negative to give to the base. As you probably just saw on there, that's what that switch does. You probably want to have a power switch in your battery so that you can turn it off, because it's on. The battery will run down because it has 4 LEDs running at the same time. Always LEDs lit, indicating the battery has been powered. Which is a good idea, good feature, so that we know that the transistor is not bad. The transistor is always bad, because if they didn't light, we know that the batteries are dead. Anyway, same thing goes with PNP. You got 2 transistors, you got 2 diodes here, back to back with the cathodes in the center. With NPNs, the same thing with anodes at the center. Anodes. And that's how it works. We go to our schematic now to see how we're going to build this tester. Okay, here's the schematic I come up with. See, there's 4 LEDs, there's 4 resistors. Each resistor has to limit the current to 20 milliamps, and it doesn't matter if it limits it more with 2 of them in series, because the thing is, it's going to limit the current so it can flow to them both. It doesn't matter if it limits it more than 20 milliamps, because most LEDs will run off of I mean less than 20 milliamps. So most LEDs will run off of less than that. Anyway, the switch here, you see here, the switch in the middle goes to the base. The CN is a transistor you're testing. The base is connected to the middle pin, and it goes to the switch between positive or negative. It chooses which polarity to use. Then the two side pins, doesn't matter which pin they go to. It could be a emitter or collector. Doesn't actually really matter. And we need to do this only when it works. Only the top or bottom LEDs light. You should only get two LEDs on one side. When you flip the switch, you should get all LEDs on at the other side. When you have all LEDs are turned on, that means you have an open circuit. When you have three LEDs on, that means you have a short circuit only on between one pin and base. When you have two LEDs on, that means you have a short circuit between base and all pins. And basically, that's how the circuit works. Very simple, easy tester. The thing is, it might be best to get a LED with built-in resistor so you don't have to worry about getting these resistors like I did. And they work pretty well. Because what will happen is that when this LED, whenever it switches on, the transistor will conduct. And then let's say this was a PN transistor. Or PNP, whatever type it is, that polarity that happens. What will happen is that when it conducts, it'll be short-circuited here. That not a short circuit is a bad thing, there's a good thing, because what will happen is they'll turn the other LED off, because LED won't get no current, because it's short-circuited between it, and then they'll only turn this one LED on that side. Same thing to the other side. If it works, it'll go to there, then there, and have nothing to go between there. And that's how it works. I don't know if these 470 ohm resistors will do the job. I believe they will. You may have to lower it. You might have to test it with a trimmer on it, a trim pot, or something where they'll where we could trim down the resistance up or down, and try to get it to light up, both will turn on at the same time without it drawing too much current. Might want to put a series resistor in series with it. That's why it's best to use LEDs with built-in resistors, so you don't have to worry about that, like I did. Anyway, now let's go to try using it. Okay, I got it turned on now. As you see, the lights are lit up on it. We're going to put in a broken LED. This LED is broken because the time that I used it, I put too much power through it, and it fried it. Anyway, let's see what it does with this. So we're going to put to emitter, collector, doesn't really matter. Emitter and collector, the side pins, and the middle's base. So if I put this, clip that to there, clip this into there. Then take our base pin. This is a PNP transistor as well. As you see, you get two lights, LEDs there. Now if you flip the switch, you get two LEDs on the other side. That's the sign it's bad, because you should only get two LEDs on one side, four LEDs on the other side lit. If you get more, we got two of the same kind, that means it's bad. Now let's try a working PNP transistor. Take our base pin, connect it to the middle pin. Okay, you get open circuit on one side. That must be for the NPN mode. If you flip the switch where it goes over to PNP mode, as you can see, it's touching over the leaders come off the middle of it. But anyway, it was. Hang on. Okay, one side conducts in PNP mode. NPN mode, now has open circuit, which is telling us that that transistor is good. Now we're going to try our PNP Darlington transistor. Even though it's Darlington, it'll give us the same results, because it's the same thing. It's the two there's the junctions it uses. Goes base, and the other two pins don't matter. As you can see, we're in NPN mode, and all LEDs are lit. Now if we flick the switch, in PNP mode, the two LEDs are lit, indicating it's a good transistor. Now we can try testing for diode. I'll show you what happens when you test for a diode, how it works. You can test diodes on it too, not just transistors. I don't know about xenodiodes. Xenodiodes will probably have current flowing both ways, which probably can't detect if it's good or bad. So let's get a diode. I got this. It's a 1N4 148 switching diode that I got. Okay, as you see here, there's three LEDs lit, one side. Now if you flick the switch, you got four LEDs lit. That means you got a good diode there. Now, if that was a transistor, that would have made the transistor was bad. Because that means that only one side, would mean only emitter and base conducted, or collector and base collected. Only one of it did, not both. And you might get that with a bad transistor. But don't think that means that it's not a diode. It means it's a transistor, but it's bad. But if you tested a diode, and you get the 3 LEDs on one side, and you get the 4 LEDs on the other side lit, that means it's good, because the 4 LEDs is what means it's in reverse. In fact, you can use this to tell what the LEDs are on. Which lead of the green wire the anode or cathode is connected to, on which lead. I believe that the guy hooked to this connected to the cathode. And what was it? PNP mode. So you'd have one of the junctions that go to the opposite. I don't know how to explain this. It'll be one of them are off. Let's try switching it around and I'll show you. I'll switch it the opposite way. This time we'll take the LED and take the diode, and we'll put the cathode on to the emitter collector leads, and the base lead to the anode. If you switch to this the other way around, look, we get the LEDs lit, and you can see it's different. You can see that it's a different what you call it, a different size lit. It's a different corner is lit on there, meaning it's the other way around. You can then by doing that, you can figure out which lead is anode, which is cathode. So I don't know if you can test silicon. I don't know if you can test silicon controlled rectifiers, because I tested one with it and it went both ways conducted. I'm thinking what that means is this because the junctions switch on and off, acting like a diode. Well, maybe I didn't have it hooked up to the white pin. I don't know. But anyway, you can test that out, fine, and tell me how you, because I don't know where my silicon control rectifier went. I know MOSFET doesn't work with it because the gate pin has too much resistance to turn the LED off on a short. You can use this also probably to detect LEDs with current limiting resistors built into it to tell if the LED has a current limiting resistor in it with this junction tester. Because if it was, because like I said, if I take got a fifth one of these, because I bought these off eBay, the ones I got into that have the current limiting resistors. Come with a fifth one if I can find it. Okay, I got it hooked up. Found it. It's a white one, as you can see. You can see it's lit, and then you can look up on there, and you can see that all 4 LEDs on the top are lit. That's because there was a current limiting resistor in it, causing this LED here not to short out any of the junctions between the sections between these four diodes. So it's lit between these two diodes, I should say, because it's connected to only between one section and then the base wire. And if it was like a regular LED, let's test that out. Hang on, I'm getting it. Okay, it's in reverse bias right now because the LED's off. You can see there's 4 LEDs lit, but when I put it in forward bias, as you see, bingo, the green LED shuts off, and LED lights indicating that LED there does not have a built-in resistor. And if you're going to put it into a circuit, you have to make sure you limit the current on it, otherwise it'll break the LED. And that's why the junction tester could be used to tell if the LED has a resistor or not. Because what causes it, because you'll know, because if it's on and you see when the LEDs here just shut off, then that means that your LED has a built-in resistor, because the resistor causes it to not short out, because it's made to run at that voltage. They don't short out at that voltage, I mean. Anyway, I might be selling this on my store if you want to buy it soon. It'll be on my store soon. So I hope you enjoyed this video. Thanks for watching. Hope you like it and subscribe. And don't forget to check out my store. Coupon code YouTube 2018 gives you 4% off discount on anything you buy. Well, that's it for now. Thanks for watching. Hope you like it.